Awesome. Welcome, everyone. Thank you for joining us today. I'm George, and today we'll be talking about data visualization. This is Deep Learning Adventures and Fun and Engaging Meetup, where we talk about deep learning, but also data science for the last couple of weeks. I'm joined by my two great friends, Robert today and Alana. Alana and I will be talking a little bit about visualization, as well as great friends from all around the world. Welcome, welcome. If this is the first time you're joining us, you can find us on Meetup if you look for Deep Learning Adventures. And I posted on the Zoom chat here the links to our Slack. If you want to join us there, we have some active channels if you're looking for new opportunities, if you're looking for some coding challenges, or if you're having trouble with any of our coding exercises, we usually interact there. Or if you just want to show us what you did last weekend, we also are pretty active there. We share pictures where we went and what we did. In terms of content, for the last 2 weeks, we've been following these Kaggle Mini Courses. And I posted a link as well there. We'll be going in detail in one of the courses today. And in terms of our next session, I also posted a link there. I'll be talking a little bit about it in the next, towards the end. Cool. I'm admitting a few more people. And if you don't mind muting yourself until we open it up for questions, that'll be great. Thank you. Cool. Let me share my screen. Or Alana, would you like to kick us off? If you don't mind saying just a few words about the meetup and the Kaggle, and then just diving in.
Oh, sure. Well, I guess, yeah, with the meetup, I don't know, I mean, I only joined it a few months ago, but these guys started a bit before that this year to talk about deep learning mostly. And we're not doing that today, but it's just for people to get together, go through some more applied type stuff, which is pretty helpful. I mean, I know I personally really enjoy that when there's like a challenge or something. Had a few speakers. Yeah, for anyone that's new, there's a Slack channel to join. On the meetup page, there are links to all of the resources that have occurred so far, kind of grouped by presenters. Like there have been some people that have come and spoken, which has been really nice of them. And some coding challenges, and also the TensorFlow in practice. I wasn't here for that, but all of those resources, again, are on the meetup page, which is pretty helpful and great to be able to go back and refer to for anyone who is interested in checking that stuff out. And so the recent one starting, was it this week that it started? On Wednesday was the first one? No, last week was the first one. Were these Kaggle Mini Courses. And so a couple of us will just check those out and go through them and explain what we did with, what I did today was I kind of did a separate notebook also, sort of like David did before and Robert did last time. But the idea is just to go through topics and learn together. I mean, that's what it's all about. And, collaborate and be fun about it.
Exactly.
For George.
It has to be fun. If it's not fun, it's not worth doing.
Yeah. So just, welcoming all of that sort of thing and just, try to learn together. That's my unprepared spiel on it. And so, yeah, today the topic is visualization. And for those of you that know, yeah, it's the Kaggle Mini Courses. And I'm just going to cover the first, well, it's 3, but it's really kind of 2 because the first one is just an introduction to Seaborn, which almost suffices to say that it's just a wrapper for matplotlib. And I don't know if there's anyone that is really completely new, just chime in with questions at any time. The first couple of sections are covering line plots, bar plots, and heat maps. And so I just kind of put together a notebook where I ran through some, post your questions in the chat, where I ran through some examples of doing that, basically. And so I'll just go through that with everyone, and hopefully following a notebook isn't too obnoxious. And it should cover everything that was mentioned in the Kaggle Mini course, which is pretty much like an introduction to plotting. So let me see if I can share my screen.
Yep, you should be able to.
Okay. Can you see everything, or is it just?
We can see your desktop.
Okay, so like everything?
Yeah.
That's fine. I'll just make this bigger.
Just make it bigger. There you go.
Okay. Yeah. So I mean, like with visualizations, you know, in general, the way that I kind of think about it with the data science stuff is there's the exploratory and then there's the explanatory, and a lot of it can kind of go either way. And with the line plots in the Kaggle Mini course, they gear it more toward the explanatory one, which kind of makes sense because, you know, line plots, you know, time series based generally. It's something that you would want to, well, actually that's not true. I'm going to take that back. It can be exploratory as well. Anyway, and the importance of visualizations too, overall, I thought this was kind of like an interesting statistics that I heard a while ago, is that people retain 80% of what they see and what they do. And like, I think it's like only 20% of what you read and only 10% of what you hear or something. So visualizations in general are really important. And of course, we all know from our own human experience that like visual learners, you know, seeing things is pretty important. So it's really helpful with data science and stuff like that to be able to keep in mind like what you're trying to say and why, and not like just make them too complicated for no reason or anything. And kind of like jumping ahead to heat maps, like I remember before at one point, like I was showing someone something that I did and I had like a heat map, just kind of like not on purpose, of a confusion matrix, which isn't really that helpful. It's not really that informative, but because it was colors, they were like, oh, that's cool. And I was like, well, but do you even understand what it's trying to say? And they were like, no. I was like, okay, so I'm not going to like include that, like, but just the color is something that people really like to see. So especially if you're trying to explain something, it's good to think like, what kind of plot do I want to use? Try to keep it minimal, try to keep it elegant. And also kind of tying that into Seaborn, that's where Seaborn can come in really handy, because even though you can do a lot of the same exact stuff in the same exact way as Matplot, it kind of just like looks better. And this is just also kind of a fun fact that I remember about Seaborn. Like, does anyone know why the alias is SNS?
Oof.
Like, I mean, it's kind of like an annoying just piece of trivia. And I've never seen this TV show, but it's because of the West Wing TV show. Like, and I've never seen, but there's like a character on it, I think, whose last name is Seaborn, and their initials are SNS. Like, I don't remember the full name, but I just thought that was really, really kind of funny.
Is great. Okay, cool.
Yeah, so you can tell someone that at some point. And so the
Elena, before you start, do you mind zooming in a little bit so that everybody can see a little bit better?
Yeah, what's the shortcut for zooming in?
Just do Control+, or if that doesn't work, then we can do something else.
Oh, there we go.
There you go. Perfect.
Thanks.
That's it. Thank you.
Great. Yeah. So line plots. Oh yeah. So I just always pull in NumPy, and look, we're not really talking about pandas this week, but I think, well, it's always there anyway. Usually there. And so I chose a data set that was stocks. That's like perfect for line plotting. And this was just like something kind of fun that I did learn from the Kaggle Mini course. Was like, normally I would take the date column and like cast that as a to date time, like here, and then, you know, overwrite that. But they had this thing that was just parse dates true and set it as the index in one line, and I had never seen that before. And so that worked out really well, which I thought was pretty cool. And so then with this data set, it's just like a bunch of companies like Apple, Google, Starbucks, you know, whatever. And since it's stocks, it shows the day, the high, the low, the closing price, and the volume. And to kind of keep it brief for this evening, I'm just going to use the closing price. And so we've just got like the date and the closing price to kind of think about today. And yeah, so this was just a couple of things that I did earlier on. So with the line plot, yeah, here I'm just kind of double checking that the date's going to be the index of the series, and just the closing price are just regular old numbers for the Apple company. And then the first thing in the Kaggle course was just, you take the data, you throw it in, and you get a plot. I mean, and it really is that simple, just SNS line plot. And with the data here, obviously I can't throw in everything because it's a multi-column data set. So I'm just saying the closing price of everything. So this is pretty horrible, like it really isn't informative. It's basically just a success in plotting something, and that's kind of it. Although you do see that there's dates on the bottom. So not needing to maybe specify those is kind of a nice feature of being able to just throw it in there. And with
Alana, does the closing price include 3 numbers, or is there some kind of a standard deviation shown there?
No, this is just because there are. I think that it's just the Seaborn line plot. Well, actually, I don't know. I should just say I don't know, because I'm a little bit further down here. I mean, the next thing I do is I just plot 1, and you see there is no standard deviation involved here.
I think what's happening is you're getting downsampling on the plot, and those big spikes are big price moves that just aren't visible in the resolution of the x-axis. Yeah,
it's just that they're all being plotted together, and there's no separation between them, and so it's all blurred. So that's so I think that like all of this, this just must be that like all of these together without any sort of differentiation of color or anything. Just kind of
if you could stretch that out about 10 times wider, you see those things resolve into a single line. Apple stock is especially around that spot where you have all the spikies was very volatile.
Mm-hmm. Yeah, and so with the line plot, the SNS line plot, I mean, like I did up above, you can just throw in data and then it'll plot everything, and here again, like I'm specifying just the Apple, just to choose a subplot of one of them, to kind of explore the Seaborn plotting, and then the closing price of just that one. And I don't need to specify whether it's the x-axis or the y-axis here. If I did, I would have to do both, but it just knows that the index is the x-axis for the dates on the bottom. And then I'm just saying the label here, naming it Apple instead of AAPL. And then the default is upper right corner, but because this goes over to the right, I just say upper left. And that's kind of just a simple example of a subplot, line plot, time series data. And then the next thing I did was just 2 at the same time. And so I've got Apple and Starbucks closing prices. And then this is just kind of like tying it back to the point of visualizations being like explaining something to someone, is that you, of course, like, with your eyes, you can look at this and say like, okay, so since the year 2005, Apple is like really winning. And so there's a conclusion, and it's helpful to see the data, of course. This is the point of visualizations. And does anybody have any questions about that? I know this is kind of like, it's not really like a deep dive. It's more like a wading in a pool, but still. Any questions from anyone?
I like that you picked your own data set and you're exploring your own data set. I like that.
Yeah, thanks. It's sometimes I find it like easier to just kind of keep the thought process in a way. And so then moving on to the bar plots, I'm kind of keeping the same data set. I didn't want to jump around too much. I did change for the heat map because it's kind of difficult to find something with the stock prices for heat maps. And so I started off with something really simple, which is, you know, bars are really great. Like, you know, you can have two numbers, but like turn them into variables and then make a bar for each number so you can see how much bigger one is. Like that's very entry, well, yeah, kind of like an entry level into bar plotting. And so I just chose this date here, August 9th, and made a variable for each Apple and Google. And then this was kind of fun. I didn't know this before. Like originally I had the line in this series. So there was like the index number and then the value for the closing price. And I had like the stocks and then had to like, you know, loc the row number, but then I realized you could just cast it as a float and it just gave me the number without needing to look at the series to find out what index number it actually was. So I didn't know that was going to work. So that was kind of cool. So then I just have the two numbers. They're saved as variables and then plotting them. And this is PLT. This is not Seaborn right now. This is just Matplot. And I mean, and you can see like it's not very pretty to look at or anything. But it does show that Google is, you know, quantitatively higher than Apple.
Alana,
Yeah.
Could you go back over that previous cell? That looked really interesting, but I didn't quite catch what you were talking about with
this.
Yeah.
Right.
Thanks.
Yeah. So I was just thinking of like my first thought with illustrating bar charts with the stock prices was just to choose a day and turn the number for the closing price for two different companies on that day into variables in order to plot them. So all of this is just to turn into a variables that are hopefully like relatively easy to follow, like Apple closing price 2004, Google closing price 2004. So the index number, which is the date, this is just a filter saying like, on this date, I want to take the Apple, where it's the company Apple or where it's the company Google, and then the closing price for each of those and save those as a variable. So that then when I put them down here into the bar plot cell, it's just easier to follow rather than throwing all of this in here, if that makes sense. Does that help?
Yeah, that does. Thanks.
Okay. Great. Yeah, and then I just printed them out to make sure that they were actually like numbers. Because yeah, with the bar plots, you know, you add a list for the X, you add a list for the Y, and then you've got a bar plot. And the, you know, stylistic choices, you can make it vertical, you can make it horizontal, and I think I do that in a minute. But yeah, this is just, I mean, I'm naming these myself. I'm saying like, this is called Apple, this is called Google, they go down here. And these are the numbers, and it just kind of fills it in. And of course, like above, and like I do in a minute, you know, you can add all this sort of stuff like title, labels, you know, like I said, change it from vertical to horizontal, you know, colors, things like that. And then, because again, it's sort of like Seaborn, it's saying Seaborn. So I was like, okay, well, this is the Seaborn version of that, which is exactly the same thing, just saying SNS bar plot instead of, you know, PLT bar. And for anyone else that doesn't know too, this little semicolon, I think it's the same thing as putting plt.show, although I'm not 100% sure on that. Without the semicolon, it does like, well, I can just do it. I think this is still running. Yeah, it has this mess right here. And so it's just for whatever reason, you throw a semicolon there and it takes that away, which makes it look cleaner. So I just kind of like to do that every single time. And also Seaborn colors them on its own. So there's that. And yeah, and so then I thought, okay, well, I'll just do 4 numbers instead of 2 numbers. So this is Nike, Google, Starbucks, and Yahoo. The maximum closing price ever, not any date specified, just saving those to variables again. So it's kind of like cleaner plotting code. And then here, it's the same thing that I did above, like the PLT bar. I'm not specifying here whether it's X or Y, it just knows that because I put it first and put it second. It just looks at the lists. And so then I wrote them out instead of doing the NKE sort of thing, just because it's easier to read. And then the numerical variables, and then added a title and labels to make it a little nicer. And the figure size, I kind of like thinking back to stuff like that I've done, the figure size is something that I know I personally mess with a lot. And then, yeah, and showing here, adding color, it's like, I mean, if you wanted to use this to say like, hey, Google really is more, and you want to like draw someone's eye, then with, you know, the matplotlib, you have to give it the colors that you want. So I just did that here with pink and gray. And then here's the example. I'm going to go down, sorry for the scrolling. Here's the Seaborn example, which is again, the exact same code, except for SNS bar plot. and then it colored them on its own, and it gave them all different colors. So that's one thing that it does differently with bar plots. Seaborn is generally more helpful for more complicated stuff. But it's, yeah, but it's also, you know, great for all this too. And here I just did an example of the horizontal, because I know like for me, generally when I have numbers and when I have words, I kind of like to put the words horizontal just because they're easier to read, in my opinion. So I just did that here, and all I did was, I didn't even bother changing the order. I just put y equals this, x equals this, and so it flipped them. And I think with matplot, it's bar h, meaning bar plot horizontal, if you wanted to change that. So pretty straightforward here, like, you know, still just specifying your x-axis, specifying your y-axis, and then a couple of simple things to add clarity, like the Y label and the X label here and the title. And also here, this is kind of like, you know, because Seaborn is just like the wrapper for the whole thing. Like that's only changed here with the actual plot object itself, but then with kind of like the adornments and things, those are still PLT, those aren't SNS. And so then I'll move on to heat maps. Yeah, and again, I did, just for like not jumping around with data sets, I did a heat map of the stock data, but it was just like, I don't know, I just thought it was kind of like totally pointless. Because with heat maps, and I wrote it here, because I found this really nice summary for what they are: two-dimensional graphical representation of data, where the individual values that are contained in a matrix are represented as colors. And heat maps, like when I think of them, like they can be used for all sorts of things. Like all you have to have, like it just says there, is a matrix of numbers, and then you can make it into colors. And that's really great for, I mean, even taking it into deep learning stuff, you can do things with like, maybe I shouldn't say it too much because I don't know exactly how to put it, but like you can explore a whole bunch of different great things with heat maps. And so, but here I just kept it to correlations because I found that so far like one of the more helpful applications of heat maps, kind of like for like feature selection and that sort of thing. So because last session, I think it was last session, we were talking about housing prices, or was, I don't remember if that was a week ago.
Yeah, that's what it was.
Okay, yeah, so I pulled in some housing data. This is the one from Iowa, I believe, that Ames one that's everywhere. So I pulled that in and did a correlation matrix here. And So what I did, because there are a lot of different features with this data set, and to try to keep it brief, so George has some time too, I just made it like anything that's above 0.5 correlation. And I guess a quick rundown of correlations are like, if one variable, because the correlation matrix is just -1 to 1. And so like anything that is a 1 is meaning that and please anyone correct me if I'm wrong here, that as one variable increases, then the other variable increases. And if it's -1, it means as one variable increases, the other one decreases. And the more it's close to 1 or -1, it just means that it's more dramatic. And
it's a stronger relationship, yes. No, you got it right.
Yeah, and so so something at 0 means that it isn't correlated. And in this instance, this is kind of a dirty way of saying like, okay, anything that's above 0.5 has a positive correlation. And so thinking about it as related to sales price, that means if it's correlated to sales price, it might be an important feature. And I'm just going to make that assumption for the sake of plotting something right now. Because also negative correlations are really helpful too. But I'm just doing positive above 0.5 right now. So this is what I just said, is that anything that's above 0.5 correlated from this correlation matrix, and I printed it out here just to see, so you can see that it's like overall quality, of course, is 100% correlated with itself. You're built, well, I mean, and actually I can scroll down here to the visual, because that's again, like kind of the point of visuals, is that they're easier to look at than just a bunch of numbers. So you can see on the diagonal that each feature is 100% correlated to itself, of course. And then with this color scheme, and I chose this bone one, I like it because it's not too bright, really, because some of them are just like really fluorescent. And so, yeah, up here, white is 100% correlated. And then down here, the darker one, it's less correlated. And so,
sorry, Lana, can you scroll just a little bit lower so we can see the full day? Yeah.
And so here I'm just kind of like looking at sales price. So the overall, so sales price. So the sales price and overall quality are, well, the overall quality is probably a good indicator of sales price, for example. And let's see what else. Oh, actually, I'm going to scroll down again. I'm going to kind of jump ahead for a second. This is something kind of fun that I think you can do with heat maps too. Instead of having the whole thing, if you want to look at just one column, like the sales price, and try to get an idea of what might be correlated, you can just look at that one thing. You don't have to look at the whole matrix, even though it's kind of fun to look at it because it's like a quilt sort of. This is an ordering of it, you know, by color. I mean, it's kind of questionable whether it's really that informative, but it's, I don't know. I just think it's kind of a fun way to use the heat map anyway.
Oh, it is.
And so,
it is. And, you know, this kind of cuts out a lot of noise, just isolating this one column.
Yeah. And so you got like, okay, overall quality, living area, garage. So if you wanted to just do kind of like a quick regression on it, you could just, you know, choose the top 5 and like make that your baseline or something. And so anyway, that's what?
It'd be kind of fun to do a PCA to see how overall quality and the other things that seem to be highly to moderately correlated with sale price go together, to see if you can reduce the dozen or so dimensions down to 1 or 2.
Mm-hmm. Yeah, totally. And here too, with this code, you can see that with the other plotting, if you can kind of like cull your variables down in other cells, like I did that, like I made this predictors one. In order to plot stuff, it's just so easy. Like all you need to do, like I don't even need if I took out the CMap bone and just did SNS heat map predictors, you'd get a plot. So it's just like plotting is really easy. But a lot of the thought that I've found, a lot of the effort is into only plotting what you want to plot. you know, and that's kind of where a lot of the work can come in.
I like that graph because it also brings to my memory the important features that we saw last time using the decision trees. So many of those features that you have in your top 5 were also in our top 5 for important using decision trees last time.
Yeah, yeah, exactly. And this is just like another kind of fun thing with heat maps too, is that you can see here that the top right triangle is just a reflection of the bottom left. So like you kind of don't really need that part. So this is something I didn't personally write this, but I did find this, which is a great way to mask that top part into just white. So you can just look at what you like, look at each actual individual correlation instead of all of it.
The lines in between the heat map cells, are they just the background color of the plot?
They are, yeah. And the line widths, like this is, you know, here, this is something you can specify. And sorry, scrolling again, like down here, I have line widths 1. You know, it doesn't really look that much. It doesn't look that different than the 0.5, but there are, yeah, I think it's just white. As a
yeah, it looks like the background, the sort of the background color of the plot, and yeah, just sorry for saying too much there, but grad school I was a vision researcher, and if you have kind of white intersecting lines on a gray background, you'll start to see that the intersections sort of dance a little bit. That's yeah, and that's a sort of an interaction with the receptive fields in the retina, and it's generally better to have that dividing line be kind of muted if you have to have it at all, just because you don't have that thing distracting you. And if you take a look at it, those intersecting gap lines between the cells are actually a brighter white than the annotations in the heat map cells too. So they sort of make it more difficult to focus in and go look at them and actually be able to read them, especially if you're as old as me and have to wear glasses.
Okay, there you go.
There, you see, notice the difference right there. That there, it's really easy to focus in on the numbers, and if you go down to the one with the lines in between them, the lines in between them are bright and kind of capture all the attention.
Yeah, yeah, you're right.
It's kind of like a Where's Waldo, but everywhere.
Yeah, well, I mean, and that's a great thing to think about, you know, because you want your visualizations to be easy to look at, you know, and informative, and not have too much get in the way. So
yeah, this one is outstanding. This one is really, really great.
Alana, can you sort this, sort the values so that the things that are most highly correlated clump together?
I'm not sure how one would do that here. Well, I suppose, yeah, maybe, I mean, you could sort it if you did it like the ascending order, but it would probably just be like the first column would be in order, and then you know, everything else would then not be. I've never tried that beyond just sorting one column on its own.
Yeah, I think I've seen it before, but I can't remember. It just seems like, you know, you'd want that the lighter colors clumped together. Yeah,
well, that yeah, I'm thinking that when I've seen that, it's I mean, I've always thought it's been like just like an insight from what it is you're looking at. Like if these were days of the week or something, and there was like a white band that was on the weekend or something, it'd be like, okay, well, something's happening on the weekend.
Right.
And that's just an element of the data itself. It's not something that it has to do with you sorting it. But that's I don't know, I guess that's the short answer.
So, I mean, these variables have no relation to each other in terms of there's no ordinal relationship or anything like days of the week.
Right. Yeah. I mean, I suppose you could say that like maybe the area ones are related, and then the, you know, maybe like the qualitative ones are related or something, but I don't know. It's kind of a stretch.
Thanks.
That's a good point. But yeah, that's pretty much all I've got. So, oh, well, and there was just one more bar plot that I did down here, because the bar plot with just the 2 variables was just one way of utilizing the Seaborn bar plot. And so here I just took the predictors, the top 10 predictors of the home price from the that correlation series that I had, and just plotted those. And this shows just again that with Seaborn, it's really simple to plot them, because here it's just the sales price column from the correlated data frame. And then, and I put it in the X position so it knows it's X, and then the Y, and then I specify the color. And that's really all you need in order to plot. Oh, sorry, I meant Y, yeah. Y, X, X, Y. So yeah, that's what I've got. George, do you want to take it?
Cool, thank you. Any questions for Alana? Feel free to post them or unmute yourself and ask them now. That'd be.
Thanks, Alana.
Thank you, Alana. That was awesome.
Yeah, that was great, Alana. Can you? I had a question about. Actually, 2 questions. One about the heat maps. I'm trying to conceptualize it. Could you go back to one of the lines of code where you plotted the heat map?
Sure. Can you see it again?
Yeah, I can see it. Yeah.
Okay. Which one?
Okay. Any of them? I just want to talk through it. Yeah.
Oh no, Chris hates that one. I'll do this one.
Okay.
Hate's a strong word.
So, yeah. So, okay. So, you said at some point it's really great because it automates a lot, and if you just put in, I think you said predictors, you'd get some. I'm trying to figure out conceptually what it does, and so in this case, and what it does automatically in particular. So it's plotting correlations, and it's changing the colors. Looks like the higher the correlation, the lighter the color. And is that all automated? Is that what the heat map call did?
Well, it's plotting the correlations because I created a correlation matrix for it. So like, for example, if you had data that was like numbers of a different kind, like how many times a customer came into a store, like, you know, on a Monday through Friday or something. And then there were numbers like 10, 20, 100 or whatnot. Like you can plot any matrix of numbers with a heat map. They don't have to be between a certain range. Yeah, I just chose correlations because it's like a use that I'm aware of.
But when you made the heat map call, so I'm trying. How did you get the colors when you?
The colors are right here where I say CMap.
Okay.
Yeah, CMap, color map.
Yeah, and like if I just took that away,
yeah,
I mean it would be something else. I just see like that.
Okay, so that's like a default or something.
Yeah, that's a default, and that's why.
Okay, and so the heat map call automatically applies the colors to it. Then is what it does.
Yeah, and I'm gonna go back, and this is why I put this here, is because I thought that this was a really great way of putting it.
Yeah.
Are you?
I think I know what a heat map is. I was just kind of curious about how you got that result, and that is cool. You know that you don't have to specify that. You know.
Yeah.
But let me ask my other question. Get back on the stocks.
Mm-hmm.
So a common thing that you plot with stocks is you'll have like Apple, and you'll plot the price. And that'll be the line graph, and underneath you'll have the volume of the trades, and that'll be the bar graph. Now I saw how you did, and if you want to do that with the data you had, I saw how you did a bar graph. I saw how you did a line graph, and variable was price in each case. If you wanted to do that, episode literally. Mute yourself. And if you wanted to do this, plotting the volume beneath it, I was wondering if maybe you could go up to one of the stock plots and kind of talk me through. Yeah, right.
Oh, so like if you want to do the volume instead of the closing price?
No, in addition to it, you have another column of data. It would be volume, and it would be on the same day. You had this closing price and you had this volume traded, but your graph would be that line plot that you have. But then you'd also have a bar graph on each day. You have the closing price, which is one of the line points there. You'd also have a bar graph down below it that would be the volume. And I'm trying to figure out conceptually. You don't have to actually do it, but in that code, what would you do? You create a variable for the volume, right? For Apple or something, and then and how do you make the separate graphs? Do you add another?
All right. So is this what you're talking about? Like I didn't do the legend here, but one of these is the closing price, and one of these is the volume, I think. I don't know if that makes sense. Maybe I should let George talk and
yeah,
come back to it.
Okay, that's fine.
So I know what you're talking about, Martin. So to do that, you actually need two separate plots. You cannot do that on the same one because they're different types. One is a line chart, one is a bar chart.
Right.
So you need to basically arrange them on top of each other, and somehow you need to make sure that the x-axis is also aligned properly. I'm pretty sure there's a lot.
Do you know how you do that in the Seaborn code? Like I could see how, for example, Alana plotted two stocks, and I think there was like conceptually, what would you do? Create another variable for the volume?
Yeah, one variable for the volume, one variable for the first graph, one variable for the price. One variable for the second graph, another variable for the bar chart.
And then in your plot command, you would just plot them both.
Actually, in Matplotlib, but also in SNS, you can specify, I want an X by Y plot. I want a 2 by 3. In this case, you want a 2 by 1 plot. You want 2 rows and 1 column. And then you can specify within each index. On the first one, I want a line chart, and the second one, I want a bar chart.
Okay.
Yeah.
All right, that was great. Thank you.
Yeah, so that'll go ahead and stack the plots. If you try to put them both at the same, find it with a common axis, that's it's in the billions, which is why the price was just a flat line, and the volume was was the one that was jumping up and down.
Yeah, maybe we can try this exercise next time. Yeah, you have to play a little bit with the scale, right? Or you have to do a dual axis, maybe.
Yeah, because when I plotted those, when I plotted them together, the Y axis is on a completely the scale.
Yep.
Yeah, because it tries to put them both in the same common scale, which means it's trying to scale each one of those series values, and then the one that's in the 200, the 0 to 200 range gets kind of squashed. Ooh.
So Alana, a real quick question. There's I haven't used Matplotlib in a long time, in a while. What does PLT show when you build a figure? I mean, you build a figure and then you do PLT show. Do you know? I mean,
yeah, I'm not really clear on that. Like the only thing that I remember just doing trial and error when I was learning it was that it just showed the plot. I think there's probably someone here who actually knows, but it just seemed like it didn't have that one line that maybe specified what kind of an object, some of the information on what it was. Like the semicolon removes this one line of information, and I'm not really clear on what that is. And I think plt.show does the same thing, but okay. I'm not real sure.
Thanks.
Yeah.
So I think when I've used it when I construct like a visualization that has multiple sub visualizations, and then I don't want to show them one at a time as they're developed. I just want to show them in the end. So you create them maybe in a loop or something, And then at the end, you just want to show the final result. So you can do the PLT show there.
Yeah, I think that does something with when you have the two axes and the different scales, like we were talking about before.
Mm-hmm.
But I forget exactly.
Yeah, cool. Thank you, Alana. Let me share my screen. And we can continue our journey in data visualization. Cool. So, Alana, thank you for covering the first three modules. For anyone looking at Kaggle, I just want to give you a quick preview of some other visualizations. So this is, I think, football, soccer rankings for different countries. So you can see here how they look like. Let's see what else. This was another one. This was another example of museums in Los Angeles. And you wanted to visualize which one was more popular for which week or for which month of the year. So you can see that there was an event for this Firehouse Museum in end of 2014, and there was a spike in visitors. You can see the trends as well. There's seasonality here as well. You can look at one at a time. I'm just quickly skimming through some of the things that Alana covered, just to give you some more context. Another one is looking at reviews for video games. So different platforms on the on this index, and as columns you have different categories, and the numbers are how popular, what is the average score for that genre. So for, let's say, we in adventure, the average score is 6 out of 10. So then you can visualize the platform and what is the average score for racing for different platforms. So you can see which platform does the best or the worst for racing games. And then if you want to look at everything at once, like Alana was explaining, then you can use a heat map where now your x-axis is genre and your y-axis is platform. And the number, if you look at the combination of x and y coordinates, it gives you how popular that game is, or that genre and that platform is. Cool. Awesome. Okay, so the next one is scatter plots, and let me zoom in a little bit. So scatter plots, let's see what libraries we need. We need pandas to read the data. We need Seaborn to do the visualizations. I was looking at this matplot converter. I don't know if anybody was curious, but apparently when you import pandas, it overrides some of the default settings in matplotlib. So I have a link here I can share with us that I find interesting on basically what is the purpose of this command. If I can find my chat. I'll share it later. Oh, there it is. There you go, scatter plots. Then we need the data. In this case, we're going to look at a data set for candy, and we'll explore it a little bit in the beginning and then see what visualization is more appropriate for depending on what questions we have. So again, we're going to use pandas. We're going to read CSV. We're going to read the CSV file using this read CSV method. We're going to give the path of the file, and this is relative path. So this is Kaggle notebook. If you're doing this from Colab or your own notebook, you have to give the full path here. And as an index column, we'll give the field ID. This kind of presumes that you know the features of your data. So it assumes that somehow you had visibility to it and you can see it. So you can experiment without the index column. You can look at it and then you can come back and read it. So this is how the data looks like. Each record is a different candy, and the first field is the name. Then if it contains different ingredients like chocolate, yes or no. If it's fruity, yes or no. Caramel, What is the sugar percent? So the higher this number, the more sugar it contains. What is the price percent? The higher this number, the more expensive it is. Win percent means how popular it is. So the higher this number, the more popular that candy is among this data set. Yeah, and this is a short explanation here. Okay, so if you want to look at, let's see. Question is, do people tend to prefer candies with higher sugar or not? So how would we visualize that? So we want to look at two variables here. One is the sugar percentage and the other one is the popularity or win percent. And SNS and Seaborn, you can do that with a scatter plot, which is basically, think of it as a whiteboard where you throw in every dot is a combination of a specific sugar content and a specific popularity. So each dot is candy, and each combination here of sugar percent and win percent uniquely identifies a candy. It's kind of hard to tell what's going on here. It doesn't mean that the more sugar you add to your candy, the more popular it is. Is it like positively correlated? It's kind of hard to tell. Then the next one adds a regression line. So it tries to fit a regular line on this data set. And you can see that the slope of this line is positive. So you can say that generally speaking, that the more sugar you're adding here, it tends to be a little bit more popular. But again, this data set is very small and it's kind of spread out. So it's kind of hard to make generalizations like that. But for this specific data set, just looking at it from a statistical perspective, if this slope has a positive, is positive, then the more sugar you add to it, the more popular it'll be. Cool, so we saw a slight correlation between popularity and sugar percent. What about chocolate? Does chocolate make a candy more popular or not? And we will use the same scatter plot method. Our x-axis will be different. In this case, will be the price percent, how expensive it is. So we're not gonna look at sugar anymore. We substituted sugar for price now. So look at price over popularity, and we will color each data point based on if it contains this categorical variable, if it contains chocolate or not. So again, the x-axis is price. So the more it is, the more expensive it is, the higher it is. The y-axis is popularity. And now the color, yes, is blue if it contains chocolate, a specific candy, and orange if it does not.
Seems like the color ought to be brown if it has chocolate in it.
Right. So you see some kind of clusters here, right? Yeah, there's more expensive candies that have chocolate and are popular, and then there's lower ones that don't have chocolate that are less popular. But let's see, that's kind of the trend that I see here. Okay, so let's investigate chocolate. So we want to create now two regression lines, one for each subpopulation if it contains chocolate or not. So in blue is the population that contains chocolate. And a regression line with a positive slope means that the more expensive a candy that contains chocolate is, the more popular it is. And the opposite is the case for the candy that doesn't have chocolate. So the more expensive a chocolate that doesn't have, the more expensive a candy that doesn't have chocolate is, the less popular it is. See, the orange line is downtrending. Oh, that interesting. Then another one, if you wanted to look at popularity of just based on chocolate, if it contains chocolate or not, you can see that this, so we use a new visualization here called swarm plot. So our x-axis is this categorical variable chocolate, if a candy contains chocolate or not. And y-axis is how popular a specific candy is. So x and y, and the color is blue is contains chocolate, orange is not. And you can see that these higher numbers here indicates that adding chocolate tends to give you more popular reviews.
Yeah, it's jittering those along the x-axis to get that effect, isn't it? It looks like a jitter plot in R.
Mm-hmm. Yeah, I'm not familiar with R, but yeah, you're talking about these lines here where there's multiple.
Yeah. If it didn't do it, then you have just blue dots and orange dots in a straight line above yes and no. And what it does is it randomly adds a little bit of X displacement so that it can spread the points out a little bit.
Yeah. Let's see, anything else? No. Before. Yeah. So that was for scatter plots. And this is a great way to visualize two variables in one chart. If you have three, you can add color as well to it, so you can have almost like a 3D visualization. Cool. If there are any questions in the chat, let me know. Awesome. Okay, next one, distributions. Let me zoom in a little bit more. So the distribution, we're looking in this case, then this course is looking at medical data set, and it's looking at microscopic images for breast cancer tumors. And it's looking at, they're labeled as either benign or malignant. And again, we import our libraries, import the data. In this case, we have two CSV files, B for benign and M for malignant. So let's look at them, how they look like. So we did a CSV. Again, we assume that we somehow imported it before, and we looked at the column that would serve as an index, and that's the ID column for both. Let's look at it, how it looks like. So each record now is a separate image, and the diagnosis could be B or M if it's benign or malignant. The radius mean, the texture mean, perimeter mean, area mean, smoothness mean, compactness mean, and all that. There's an interesting video if you're new to this. I found this video really interesting here. I can post it on our chat of how this classifications were done or how this labeling was done. There you go. Okay, so let's explore the data a little bit. And then, so that was the file for the benign one, and this is for the other case. And there's some questions here. Then we wanted to look at what is the distribution basically of one variable. So we wanted to look at the area, the average area of a tumor, and we wanted to look at, in the case of benign or not, what is the minimum maximum value? Where are the most values around which area are they most gathered? So you can see that for benign, distribution is kind of tight, and it's centered around, a little bit less than 500. I think this is, I need to look at the units, but this could be, millimeters or nanometers, I'm not sure. I need to look at the units. And for the malignant case, you can see that the distribution is much wider, and there's an overlapping area here where it's kind of hard to tell just based on the area. So that was using the plot, the distribution plot, where you specify your what variable you want to plot, and you can call this multiple times. You'll just add another distribution on top of it, on top of the other. And if you call PLT legend, by default, it doesn't plot it. So you have to force plot it here. That's just a little bug, I think, in SNS. Cool, then instead of histograms, if you want to look at a smooth version of it, and I think this is doing some kind of approximation, you can use what is called a Kde plot, which is similar to the histogram, but now you can see that distributions are much smoother. It looks like a distribution from a continuous variable instead of a discrete variable. And this is easier to read. Yeah, so this is plotting distributions. kernel density estimate. Yep. Yep. Yeah, it's a density function. Yep. Awesome. Cool. Let's look a little bit about different types and styles. That's important. So we'll use the dataset from Spotify, and let's look at it, how it looks like a little bit. So the x-axis is date, when was a song released on Spotify, and each series is a different song. And the legend here tells you the title of the song. And the y-axis is popularity in terms of streaming, how many people streamed it on Spotify. So it could be, you know, all the way to close to 1 billion people here, you can see, or hundreds of millions. And you can see some kind of effect here. For example, Despacito here took off April 2017. And the whole point here was to use, so this is the default, no, this is not the default. This is using a style from SNS called dark. And we'll look at other ones as well.
That's
so
a weekly seasonality in there. Is that what that is?
I don't know if this is
those are months, right? On the x-axis.
It
Looks
actually
like
the
days.
data has days.
Actually, no, they are months.
So yeah, it looks like it's about weekly seasonality in the popularity of various songs. Interesting.
Yeah.
People would download on the weekends a lot more than during the week, I think.
That could be.
Could be, yeah. So then I just want to explore the different styles here, and I just created a method that accepts data, what is the size of the figure, and what is the style. And there's 5 different styles, and let's look at all of them. So this is the dark grid, the white grid. This is the background, basically. Just dark, no grid. Maybe that's easier, like Chris mentioned, without the X and Y split there. This is just white, no grid. Ticks, I don't see a significant difference between the previous one and this one. It looks
it's like on the actual axis, there's like little lines where the where the X and the Y label, not the labels, but you know, the
I see.
entries are, yeah.
Got it. Yeah. Let me actually look at the theory for that, because I'm interested in the data set itself. I think it was line chart. Let's see. Okay. Yeah, so it's days. The date is days. So you see January 6th, 7th, 8th, 9th, 10th. And that's the same plot that we saw, just compressed. So yeah, that's the weekly seasonality you were talking about, Robert. Here. Cool. I wanted to share with you this nice summary. Let me see if I can find it. Yeah. So we've seen different visualizations by now, and the question is, okay, what do I use in which case? And I like this diagram here that kind of summarizes everything. So you start here in the blue box, and the question is, what would you like to show? And you have 3 options. You can show trends, relationships, or distributions. So if you want to show trends, some kind of how things look over time, maybe time series, then you can use Sns Line Plot here. An Sns Line Plot, we've seen that in the past, like Alana explained it. You can basically, you have x-axis time and y-axis could be a metric, continuous, discrete, doesn't matter. And you'll see how it changes over time. If you want to show relationship, and let's say you have multiple options depending on what kind of data you have and what you're trying to show. So for example, With the bar plot, we saw that if we have categorical variables as our x-axis, it's very easy for us to distinguish them, and the y-axis could be anything, continuous or not, or discrete. If you have two variables that you wanted to show some kind of correlation like Alana showed, or some kind of how they're related to each other using a third metric. Now, the third metric here, that number would also be coded by the color. So this is almost, I would say this is a 3D visualization, but plotted on 2D using color as a third dimension. If that is overwhelming, or if you have two quantitative variables here, let's say you have, how big is, what is the space, let's say the square area of a house versus price, and each data point is a house, then you'd use a scatter plot here, and you could see how they, what if there's a trend, if they're positively correlated or not, and then we can see different versions of scatter plot by adding regression lines. Yep, right here, regression plot, or if you have multiple lines as well. So if you want to see some kind of statistical model behind your data, you can use this regression plot, reg plot. And if your data contains subgroups, in this case, we're using color to distinguish between smoker and non-smoker here, then you'd use LM plot. Another visualization is this swarm plot that you can use, where each x-axis is categorical, and the y-axis could be quantitative. Then for distributions, you can do a distribution plot, this plot. You can do a Kde plot, which is a smooth version of a distribution and kind of approximate version of it. I'll go to a notebook and we'll look at the joint plot as well. We didn't see that yet, but think of it as you have two variables that are correlated. And then you want to see how, in what axis and what dimensions are they correlated. Not only that, but on top of the x-axis here, you see distribution for one variable, the width in this case of a variable, and in the y-axis you see the distribution of the length of it. So I just realized I went through the coding exercises, but I think the theory of each of these modules was interesting as well. So if you don't mind, let me quickly share with you what was the theory for each of these modules. So for the scatter plot, this was a synthetic data set using insurance charges. And it had fields like age, sex, BMI, smoker, non-smoker, what region, and charge. Again, this is a synthetic data set. And we wanted to see how is insurance charges correlated with BMI, which is the body mass index, which is basically your weight divided by your height square. So looking at this scatter plot here, it's kind of hard to tell what's going on. And even using a regression line, you can kind of make reach the conclusion that, yeah, the higher the BMI, the more charges you're getting in terms of insurance. But you can see there's kind of two populations here, subpopulations, you can see them. So let's take a deeper look. So we use scatter plot, but instead of just using now X and Y axis, we're going to give a third variable or third dimension, which is hue, which is basically the color. And that will be if you're a smoker or not. And orange means you're not smoking, and blue means you're smoking. Again, this is a synthetic data set. But you can see there's two subpopulations, how they look like. Then if we want to use this regression line for two populations, we have this LM plot. And you can see the orange one, it's not as steep as the one for the smoker. So the steep line here means that the higher the BMI for you, the more charges, or the more maybe visits you'll have to the doctor.
There's an interaction between smoking and BMI there.
Yeah. You can look at this the same from using the swarm plot. You can see that most of the non-smokers are in this low regime in terms of charges, and this non-smokers, they can spike up to these high numbers. I find that interesting. And also about the data set, interesting as well. So that was scatter plots. Let's look at distributions. If you've done machine learning or any kind of data visualization, you probably come across this data set for this iris data set. So there are three types of iris flowers, the setosa, the versicolor, and the virginica. And you're trying to measure, you're trying basically to build a model, or you're trying to detect, by two simple readings, can I tell which type is a flower I'm looking at? And I have some other visualizations here, but you're looking at the sepal and the petal, and you're looking at the width and the height of each one of them. I found another visualization here that make it a little bit easier. It wasn't immediately clear to me, but basically just looking at these two readings or four readings, can you tell what version or what type of iris flower you are? Let's go back. There you go. So let's examine the data. So each record is a flower, and you have the length, the width, the petal length as well, and the species. What is this? Is it setosa or versicolor or virginica? So let's do some histogram. Let's look at just the petal length. So you can see there's a spike here in the low petal length, and there's some other data sets in the higher petal length. You can use a density plot, which is a smaller version of the histogram.
Hang on a sec. Stop scrolling, because we've got some questions about the difference between the KDE and a histogram.
Okay.
Yeah, it looks like the histogram is raw count data for each one of the categories that you've got, and that the density plot is more smooth and almost fit to a particular kind of distribution.
Yeah, so you can specify the bins, and when you do the distribution plot, you can also specify the bins. You can make them fine-grained, or you can make them a wider range. But the Kde is basically an approximation of this distribution plot above.
Is it Gaussian?
So this looks like a mixture, right? So I don't know.
The KDE is not fit to a distribution. It's like you run a filter across it to smooth it out. You get an estimate.
Yeah, the question is between histograms and distribution plots, not density plots.
Right. The distinction there is that a KDE is what's known as a non-parametric distribution.
Right.
You haven't decided what the shape of the function should be. So it's highly dependent upon every individual data point, as opposed to a parametric model, which you've basically decided it's going to have a certain functional form, and you fit X number of parameters to that model.
Cool.
Yeah, it's not.
Awesome. Then if I want to look both the width and the length of a flower, the petal length, and the sepal width here, you can look at a disjoint distribution or disjoint visualization here, and then you can look at the Kde plot of the length and the individual Kde plot of the width on this axis. And the darker the color, the more observations you have in that XY combination. So if you wanted to look at, let's see, so we want to look at petal length, but we wanted now to label them by the different species. Now you can clearly see here the distinction that just looking at the petal length, you can clearly tell that to the left you have the setosa species, and then to the right you have this combination or mixture of the other two species. And you can do this with Kde as well. So you can tell it's easy to tell just by looking at this one feature, the petal length in centimeters. If it's less than 2 centimeters, then you're a setosa. If it's more, it could be either one based on where you fall here. Cool. I like these data sets as well. 6. 6, we looked at this already. This is the different styles and what kind of visualization you want to choose. And for 7, 7 introduced us to Kaggle datasets, which is a really cool and beautiful place where you can find different datasets. And the beauty of it is you can see how old it is, how how many files it has, what's the size of it. You can also see how popular it is. So this votes here means that people upvoted this data set for some reason. And you can also search, right? So I was looking for something related to pets or something related to walking or or iris or whatever you want. You can search for anything and you can find here weather, for example. You can find a data set that you could probably use for your own analysis. And we used several of these data sets in our coding challenges, if you remember. So let's say I'm interested in this Austin weather data set. If you click on it, you'll get a description of the features. If it came from a specific source, it'll be acknowledged. Then you'll get a preview. In this case, I'm looking at the 10 out of 21 columns. There's a date column. This probably will be our index in our analysis. Usually you get 3 metrics or 3 numbers for any metric: the high value, the average value, and the low values. In this case, for temperature, for dew point. This is very similar to the Madrid time series analysis we did. Then the easiest way to do is you can just click on new notebook here, and I'll show you another way of, if you're already using a notebook, let me see. So let's go to one of my notebooks here and let me do edit. So if I'm in my Kaggle notebook, and if I go to this option to the right, there should be add data here. If you click on it, it will bring you the same dataset menu. And if I search for weather here, let's say this Austin weather, I can do add. And that what that will do is it will actually download it on my Kaggle notebook. And under now input, I have this Austin weather CSV. And if I click on it, let me zoom in a little bit. You can see here at the bottom that I can see a preview of that same dataset. The path is right here: input Austin weather.csv. So that's one that I can use in my notebook. Let me show you the one that I chose for another one. I chose okay. I chose this dataset called Run or Walk, and I want to share that with you. So let me go to the dataset. Sorry. Let's do another search. So this is a dataset from reading. Somebody was wearing, looks like holding a phone. And you could be either walking or running. And all we have is the different metrics from your app or your smartwatch in this case. So you can have acceleration, you can have gyroscope readings, and it could be on either dimension X, Y, Z. And the interesting thing is to look at, can you maybe build a classifier, some kind of model that based on the raw readings can tell you what kind of activity you're doing. So let me go back to my notebook. Let me run it, start running it again. So I imported a data set from here. You can see it's already imported for me. take a look at a few records, how they look like. So there's a date field, there's a time field, the username. Actually, the username is exactly the same for all of them. I don't know if this is synthetic or not. There's an activity, which is a categorical variable. If your 0 means, I think, walking, and 1 means running. And the different metrics for the gyroscopes and the accelerations. Cool. So first I wanted to look at the numerical variables, how they're related. So we saw this describe method earlier when we were looking at the Python class. How many records I have, what is the average value, what is the standard deviation, the minimum value, and the different percentiles, 25, 50, 75, and what's the maximum value. I wanted to see how many users are in the data set. There's only one. What is the time span that my data set covers? It goes all the way from June 2017 to July 2017. So about a month of data there. Then what I wanted to look at is how does acceleration look like for the different axes. So this is a line chart, and I wanted to see how things look like in terms of just acceleration. So the higher the value, the more acceleration it is. So in this case, in the X dimension, then all of a sudden here you have lower ones. Also want to look at a distribution here. So I want to see what is the range of acceleration on the different dimensions, X, Y, or Z. And you can see that they're most of the time around 0, except for this Y one that's a little bit dual distribution here on the left and on the right. So I found this interesting, this data set, and this is just the first step in exploring the data. But the goal is looking at this acceleration and gyroscope metrics, can you build a model that tells you if you're walking or running or something else? Let me see if there's anything else. I think the last one is, creating your own notebooks. And the goal here is you can just go to notebooks and you can just do a new notebook, or if you go to any data set and you do a new notebook, you can choose your programming language. If it's a notebook or a script, we usually choose notebooks. You can also integrate it with your Google Cloud services. We saw that last time when we integrated with AutoML. You can choose if you want to use a GPU, a TPU, or a CPU. And when you hit create, it'll just create a notebook for you, similar to what we've seen in the past with Colab. And here there's nothing, there's no data. So if you want to add data, click on it. If you want access to internet, you have to toggle this on. If you want to download packages, that's important. If you want to add data, let's say weather or something else, or traffic, say maybe I'll get some traffic data. Traffic signs, traffic data, computer network traffic, traffic collision. I just wanted to see, maybe this one. Okay, daily observation of traffic value volume divided into hourly bins, location. Okay, this is an interesting data set if you want to do some kind of analysis with traffic. Cool, I'll pause here. That was the entire data visualization course. Again, that's third in our journey so far. We covered Python, introduction to machine learning, and data visualization. If for some reason you'd like to review them or you didn't join us, we have this playlist that I'll share with you on Zoom as well. DLA Kaggle courses. And you'll see we have the Python and introduction to machine learning, and later tomorrow I'll upload today's session as well. And also wanted to speak a little bit about the upcoming session, which is next Friday. There's nothing going on Wednesday next week. Well, we'll be presenting as part of this cool event called Data Week DC. It's a weekly long event. I encourage you to check it out as well, dataweekdc.com. There are different meetups and organizations I'll be participating. It's a week-long event. And the goal is, just to raise awareness around data, inclusion as well as training and data literacy, basically. So we'll have a fun event around teachable machines. We'll be using a resource from Google called Teachable Machine, and we'll be using 3 models: a computer vision model, an audio model, and a pose estimation model. We'll be doing live training. We'll also be looking at the model that is built on your browser as you run this training in real time. So we did it last time and during a happy hour, and we thought it would be a great idea to do it again as part of Data Week DC. So if you want to check it out in advance, I'm posting the link here, teachablemachine.google.com. And you can see here, we'll be training live on computer vision, on audio, classification, or pose estimation. So if you want to join us, let us know. If feel free to join us. There's some cool projects that people have built, and you can learn more about it here. Cool. With that said, if you don't have any more questions, I hope to see you next week. And thank you again for joining us. And have a great weekend, everyone.
Thank you.
Thanks, George.
Thanks,
Alana. Night.
Thank you. Have a nice weekend.
Have a nice weekend. Bye-bye.